Remember from our previous chapter that everything around you is made up of two things, matter and energy. Also, remember that matter is made up of individual particles called atoms. So when we look at any given substance, we are actually looking at a collection of atoms in motion. In a substance, the distance between the atoms and their motion determines if it is a solid, liquid, or a gas. Each state of matter has their own unique properties. We are going to look at and identify the atomic characteristics of a solid, liquid, and gas to help explain the unique properties of each state. Well, what do we know about solids? Well, solids are hard and hold their shape, but why? It's pretty simple. The closer the atoms are in a given substance, the harder that substance is. There is very little space between the atoms in a solid, and for this reason, we say that a solid is not compressible, or it cannot be pressed. Similar to the way a solid holds its shape, the atoms inside a solid can't move around too much. Just like these dancers, they stay in a fixed place and vibrate next to each other. We know that liquids fill the shape of a container, but why? The space between liquid atoms is more than a solid, but they are still close together. Where atoms in a solid stay in a fixed place, close to one another, atoms in liquids can move past one another, but they want to stick together. Liquids have cohesive or sticky forces that work to hold the atoms together, similar to this Congo line. This cohesion allows liquids to flow. As the temperature of a liquid increases, so does the amount of movement of the atoms in a liquid. Gas is the final state of matter that we will explore. We know that gas is everywhere. There is so much space between gas atoms that they have very little interaction with one another and will continue to spread out until they hit the wall of a container. Because there's a lot of empty space between atoms, we consider gases to be compressible. Just like these dancers, atoms in the gaseous state move very quickly past one another and are free to move in any direction. They may occasionally bump into one another. Just as with liquids, as the temperature of a gas increases, so does the amount of movement between gas atoms. So in summary, we begin with a solid whose atoms are tightly packed with vibrational movement. As temperature increases, so does the movement of atoms. We see atoms close together and increased movement in the liquid phase. As we reach the boiling point of 100 degrees Celsius, we see only a few of the original atoms present as they are spread out and bouncing around wildly.